and I accumulate that information in a server. That information is available for the course of a year, for example. Now, I'm sure your first reaction to this is, well, only a nerd or a geek would want to do that. And that's probably true. But I have a very definite motivation for putting this system in place. At the end of the year, I have a very, very clear information about how well my heating and ventilation and air conditioning system actually distributed heat and cooling in every room in the house. And so at the end of the year, you can start looking at how to make adjustments to make the system work so it's more comfortable for everyone. So there's actually a rationale for doing it this way, as opposed to relying on just anecdotal evidence like, gee, this room seemed hot in the summer, or that room seemed cold during the winter. Now there is one special room in the house. It's the wine cellar. And it's very important to keep the temperature in the wine cellar below 60 degrees and to keep the humidity in the wine cellar above 50% so the corks don't dry out. So this room is alarmed. And if the temperature goes up above 60 degrees, I get an SMS on my mobile. This happened to me when I was visiting the Argonne National Laboratory in Chicago, Illinois, the United States. As I was walking into the building, my mobile went off. It was the wine cellar calling, saying that you've just penetrated the 60-degree barrier and your wine is warming up. Unfortunately, my wife was away on a 2-week trip, and so I couldn't call her to say, turn the cooling system back on. So for 3 days, every 5 minutes, I kept getting this little message saying, your wine is getting warmer. So I called up the people who make the sensor network. It's a commercial product. And I said, do you make actuators as well as sensors? And they said, yes. So I have a new project now to put an actuator in, so if I get another message, I can say, go turn the cooler back on. Now, someone suggested that because I can see the light levels in the wine cellar, I can tell when the lights have gone on, which means when I'm away, I may actually be able to tell that someone has gotten into my wine cellar. But it doesn't tell me whether they took anything out. So we thought, well, why don't we put little RFID chips on each wine bottle so you could do an instantaneous inventory of all the bottles in the wine cellar. And then you could tell if any of the bottles left the wine cellar without your permission. That sounded like a pretty good design until somebody pointed out that you could go into the wine cellar and drink the wine and leave the bottle. So clearly I have a bug in that design, and we have to do something like putting sensors in the cork, and so we can tell if there's any wine left. And if we're going to go to that trouble, and we might as well do something about detecting the esters, in the state of the esters in the wine that tells you how the wine is going to taste. And you know, before you open the wine bottle, you interrogate the cork and you find out the condition of the wine. And if it's really bad, then you give that bottle to someone who doesn't know the difference. So this is a very practical reason for implementing sensors in your network. We've uploaded the protocols to the renamed epoxy spacecraft. So we have 3 nodes of an interplanetary internet in operation and test today. If we complete all of our testing at the end of this year successfully, we can declare that the protocols and their implementations are space qualified, which means that we can offer them to a group that standardizes space communications. It's called the Consultative Committee on Space Data Systems. They are then free to take the software that we've space qualified and the protocol specifications and use them on any spacecraft that any of the spacefaring countries choose to launch. It's purely voluntary, but if they adopt these protocols, what we can say that what will happen is that each time a new mission is launched containing these standardized interplanetary protocols, all of the spacecraft will be interworkable. They'll be able to exchange data with each other in the same way that when you plug into the internet, you can talk to any of 700 million machines on the network. So the result of this standardization is, just like on the internet, every spacecraft that finishes its primary mission can become part of an interplanetary backbone by repurposing the spacecraft to be a communication node. And over many decades, you can actually see the accumulation of an interplanetary communication system in space that can support both manned exploration and robotic exploration of the solar system. So for us at the Jet Propulsion Lab and now other parts of NASA, we've gone from something that sounded like a science fiction story to serious deep space engineering. And there is nothing more exciting than actually making something happen. So that is the up-to-the-date report on the interplanetary internet. Next time I'm here next year, I hope I'll be able to report that it's fully standardized and that we're ready to go into operation anywhere in the solar system. So I'll stop there. Thank you very much for letting me take this time, and let's get our moderator back so we can get into Q&A. Thank you.
Bueno, pues agradecerle mucho a Vint Cerf esta plática donde pudimos ver que el futuro de Internet contempla nuevos estándares de comunicación que permitirán que los equipos móviles no saturen este espacio que, bueno, pues ya se entiende como una red que tiene que funcionar de manera ininterrumpida, y afortunadamente tuvimos la posibilidad de conocer también qué es lo que está ocurriendo con este proyecto que está realizando con NASA para el Internet interespacial.